Chapter 3, The Science of Astronomy. The first part of the chapter, we're going to talk about the ancient roots of science. And we wanted to know in what ways do all humans use scientific thinking? This is something that we use every day. And it's no difference from our daily life or daily thinking. And we also wanted to know, how is modern science rooted in ancient astronomy? So scientific thinking is based on everyday ideas of observations, trial and error experiments. The only difference that a scientist, when scientist is thinking, is that a scientist is trying to understand and make a model. That's the only difference. But the basis of the thinking of all human beings are the same. Now, astronomy turned out to be the oldest of the science. We have cave paintings that dated back 18,000 years ago with the lunar cycles. So it's one of the oldest science, and often practice it for very practical reasons. For example, for keeping track of time, seasons, agricultures, religious ceremonies, things like that. And it was also very well used in ancient time for navigation. As I said before, we do have maps, accurate maps right now. We have GPS right now, but 1,000 years ago, they didn't have these stuff. 500 years ago, they didn't have these stuff, right? So they were using astronomy and the locations of the stars for navigation. Ancient people in Central Africa, and we're talking about 6,500 BC, could predict the seasons from the orientation of the crescent moon. So in Africa, they have two seasons, a rainy season and a dry season, right? So they could see the orientation of the crescent moon. If it's leveled, if it's with this, close to 0 degree, it's in the middle of June, which is when you have a rainy season. As you go towards October, the orientation goes negative, so negative 18, negative 25, and so on. So they could predict what time of the year they are. And as it goes back to positive, it's again the end of dry season. So they knew these stuff 6,500 years, so BC. So this is a knowledge that people had for a very long time. In fact, the names of the days that we are using today, the 7 days, they were originally linked directly to the 7 objects in the sky. And the pattern is clear in many languages, including English. For example, sun, Sunday, moon, Monday, right? If you speak Spanish, or if you understand Spanish, or you can read the Spanish, you can see that it's probably a better relationship here, that you can kind of see the names of the day and the names of the object in the sky. So what did ancient civilization achieve in astronomy? So they were able to do a perfect job doing the daily timekeeping. So they knew what time the sun will rise. They knew what time the sun will set. They could track the seasons. They have an accurate calendar that we are still using today. They could monitor the lunar cycles, planet and stars motion, predicting the eclipses, and many things. As I said, navigation is based on the location of the objects in the sky. Egyptian obelisk. This is a very interesting object that shows the time of the day, and based on the shadow of the object, we have something similar in Washington, D.C., Washington Monument. So there are many examples. In England, we have a Stonehenge, which was completed around 1550 BC. They use it for astronomical observations. In Mexico, we have a model of temple. Here's a model of the Temple Maya. They found many astronomical objects buried around this temple. In United States, in Southwest United States, we have Sun Dagger, which marks the summer solstice. In Scotland, 4,000-year-old stone circle. Moon rises is shown here every 18.6 years. This number is very important. I'll talk about this number in later chapters. but this is 4,000 years old. So ancient people knew a lot, and more than probably what an average person knew in the 21st century. In Peru, these lines, patterns, and patterns, some align exactly with the stars, and a lot of people are thinking that maybe we have ancient astronomers, or even aliens coming to on Earth and making these patterns. And at Machu Picchu in Peru, the structure is amazing. This structure aligns with solstice. In South Pacific, the Polynesians were very, very skilled in the art of celestial navigations, because when you're covered with water, when you're around water, if you go in the wrong direction, you're going to end up dead. So they knew the art of navigation. They knew exactly each object in the sky, its position, its relative direction, so they can kind of navigate to where they want to go. In France, this is what I was talking about, cave paintings of 18,000 BC. This may suggest the lunar phases. There are 29 dots here. So we don't know for sure, but we assume that they knew, because they are exactly similar to lunar phases. In China, the earliest known records of supernova explosions. These are stuff are pretty amazing. This is 1400 BC. Persia, the first accurate calendar that's still in use today, and the first record of observations of Comet Halley. And, it's pretty amazing, this stuff. This object here is kind of like the star maps that we use today. If you go to a bookstore, you can probably get a star map. It'll tell you what time of the day, you can see what stars and what seasons. So this object was exactly that. And there is one, I actually saw one in St. Louis Art Museum. If you ever go to St. Louis Art Museum, if you go to the second floor, if I'm not mistaken, and then you can probably see one of these astrolabes or star finder or star maps. So just to sum up, the scientific thinking involves the same type of trial and error thinking that we use in our everyday life, but in a very carefully organized way. And we're trying to make models out of stuff. Okay, that's what the scientists do. I mean, this is exactly what we do in astronomy. The oldest of science is astronomy. It has an important practical applications for developing civilizations. Now, the question is, or for this part of the chapter, is why does modern science trace its roots to Greeks and Persians? And how did the Greeks explain the planetary motion? And what happened? At what point in time these packs of science, well-developed science, find its roots to Europe and then evolved there? So we just wanted to talk about that a little bit. So our mathematical and scientific heritage originated with the civilization of the Middle East. So this is where the Babylon is, Persia, and then it started to evolve there. This area was very good for living, because it was very, they could do a lot of agriculture stuff here. So they started to build up cities, big cities here. And so that started to go into three different directions to North Asia, through Caspian Sea, to Europe, through Turkey and Greek, and to North Africa through Egypt. So they were the first people that we know that they were trying to make models out of nature. So they're looking at nature, things that are happening around them, that they were trying to make a model out of it. So they're trying to explain it. For example, this is a Greek geocentric model of the universe. They were thinking that Earth is in the middle and everything else is rotating around the Earth. The Earth is in the stationary position somewhere in the middle. So this is a 400 BC model. They try to explain patterns in nature without resorting them to the myth and supernatural things and gods and things like that. So they were trying to understand it in a scientific point of view. So what they were trying to do, for example, Plato and Aristotle, which are the biggest philosophers in Greek, so they thought that the Earth is in the center of the universe, and heavens, planets, other stars, whatever that they must be perfect. These are the objects that are moving in the perfect spherical or circular shapes. So that's what they were thinking, and that they were putting their model based on that, a model that you can see here. Earth being in the center, everything else in perfect spherical shape or circular shapes. But the problem was, this model was very difficult to explain the apparent retrograded motion. This is what we were talking about last week, or in last video. So in a period of about 10 weeks, Mars appears to stop going from west to east and kind of go back towards the west. After that, it goes back again to east. So this model couldn't explain this type of motion, which is called the retrograde motion. Now, what happened was Ptolemy would come up with a Ptolemaic model, and it was accurate enough that remained in use for 1,500 years. It was the most sophisticated geocentric model. In Persian, in Arabic translation of that, it means the greatest compilation. So it was a very accurate in terms of predicting where these objects are. But was it the actual thing? No, because we know that Earth is not at the center. But it remained in use for 1,500 years. And let's see what this model is doing. So this model, in this model, the planets really do go backwards in their model. So let's say that this is Earth and this is a planet. Not only the planet is moving in a bigger circle, okay, but also it's rotating around a smaller circle. So if you combine these two type of motions, you see what this orange dashed line is. That's what we see, and this is where the go back or retrograded loop is happening. So this is exactly what the point that we see it in the sky, as this object is moving, does one full rotation and then go back. So this is exactly what this does. So Earth is at the center, planet is moving, but it's also rotating in a circle, or in an orbit around an object here, or around a center of a circle, but it's also moving. So what you see in a plane of the sky is this dash line. So a thought question, again, these thought questions are designed in a way that I want you to stop and pause the video, read the question, and try to answer it. And I'll go over the answer, but I want you to do it first. And I trust you on that. I want you to stop the video right now, read the question, and try to answer. So go ahead. So the question is, which of the following is not a fundamental difference between the geocentric and sun-centered model of the solar system? If you read all of these answers, A to D, you see that the geocentric model is useless for predicting planetary position in the sky, whereas even an earliest sun-centered model work almost perfectly. So, preserving the ideas of Greeks. The Greeks preserved and enhanced the knowledge they received from Persians while Europe was still in the Dark Ages. So, for example, the House of Wisdom, which is currently in Baghdad, in Persia at the time, was a great center for learning around AD 800. So they were pretty sophisticated compared to the rest of the world at the time. With the fall of, so okay, let me, this is probably not the accurate time for it, but let me update that. I'm gonna pause the video for a second, okay? So it turns out to be the correct time, 1453, when the Constantinople fall, but which is in Eastern Persia, or currently in Istanbul. But so people headed towards the west to Europe, And then they were carrying all of the knowledge that they got from their ancestors and over years and years of practicing and making mathematical models. So they carried all of those knowledge with them, okay? And then they went to Europe through these three ways that I was just showing you right here. And this map is not in the book, but it's very useful to use. So they started to going to Turkey, Turkey today, and then going to Greece. So Greece were the point where all of these knowledge get combined. Okay. So just to quickly sum up what we have learned, you know, Greeks were the first people to develop models of nature, and Ptolemaic model, which think that the Earth is in the center, and planets are moving in two different circles, one in a smaller circle and one in a bigger circle, causing the retrograde motion that we see in the plane of sky for some of these objects remain in use for a very long time. So I'm going to stop here for the first part of the video, and we'll go to part 2 after this. Stay tuned, okay?